Recording is important. Okay. So last class we were discussing about L and C elements, and let's quickly rewind the properties of L and C elements. Properties of capacitor. First, tell me what are the properties of capacitors? What are the properties of capacitor? Last time we have seen. Tell me the voltage current equation. I is equal to C dV by dt. So from this, what can we infer? Capacitor I equal to C dV by dt. So if there is change in voltage in zero time, okay, if there is change in voltage in zero time, what happens? The current will tend to go infinity, and which is not possible. So capacitor won't let the voltage change instantaneously. That means it opposes change of voltage or sudden change of voltage. Sudden change of voltage. Okay. Similarly, for DC voltages, what happens? For DC, that means dV by dt is zero. No change in voltage with respect to time, or voltage is just constant with respect to time. What happens? Current will be zero. That means for DC, capacitor acts as an open circuit. Capacitor acts as an open circuit, right? So you cannot allow an instantaneous change in voltage. Also, you cannot allow, also there won't be any, what called, for DC, it will act as an open circuit. Capacitor acts as an open circuit, okay? Next, also, what is the energy stored in a capacitor, which is equal to half CV square. So this is about capacitor. Then coming to inductor, what is the voltage current relationship of an inductor? Voltage current relationship of an inductor. V is equal to L di by dt. From this again, it opposes sudden changes in current. Opposes sudden changes in or instantaneous changes in current. Okay. So for DC that means di by dt is zero. Voltage is zero. Voltage zero is a short circuit condition. Short circuit condition. Okay. Also, energy stored in an inductor is half Li square. Half Li square. Okay. So these basics are important for the next topic. First order circuits. Okay. So inductor opposes sudden changes in current, acts as a short circuit for DC, and stores energy in the form of electromagnetic field, which is equal to, or the maximum energy stored is equal to half Li square. Similarly, capacitor opposes sudden changes in voltage, acts as an open circuit for DC, stores energy in the form of electrostatic field, and the maximum energy stored is half CV square. Okay, first order circuits. First order circuits. So people call it transient circuits. Okay, transients or first order, second order circuits. What do you mean by transients? Anyone? What do you mean by transients? I'm audible, right? What do you mean by transients?
Like when we apply an input and the response, like the immediate response of that before it going to the stable state.
Right? Yeah. Transients means the changes at t just is equal to 0 plus. Okay, the instant where change in a circuit happens. Okay, if the instant where the change in circuit happens at t is equal to 0, then t equal to 0 plus shows you something called as transient condition. Okay, t equal to 0 plus shows you something called as transient condition. Okay, transients are nothing but any changes in the circuit. Okay, a switch is closed is a transient, a switch is opened is a transient. Okay, switch is closed is a transient, opened is a transient, switch is changed from 1 to 2 is a transient. Okay, also a particular element is removed is a transient, a particular element is introduced is a transient. Okay, any changes or load, there is a change in load, sudden change in load is a transient. Okay, all these comes under transients. Okay, that's what. And when I say first order circuit, what do you mean by first order circuit? First order circuit which needs or which involves first order differential equations, then that is what you call as first order circuits. The circuits which involve second order differential equations, solving of second order differential equations, is called as second order circuits. And if third order circuits, if you have more than if you need more than two second order differential equation or third order differential equation more. Okay, in our in our syllabus we only have first order and second order differential equations. Okay, or like first order and second order circuits. Higher order circuits are not there in the syllabus, and it's not necessary particularly. Okay, so first order and second order. When you see a circuit, can you tell me whether it's a first order circuit or a second order circuit? To say that it should involve at least one independent L or C element. Okay, after reducing the circuit. Remember this, at least one independent L or C element after reducing the circuit indicates order of the circuit. I'll explain you this. I'll explain you with the example. So explain you with an example. See this. Okay, note comment on the order of the circuit. The first one. Tell me what is the order of the circuit? It's an RL series circuit. So order one, that means there is only one L or C elements. L or C elements are the energy storing devices. Okay, are the energy storing elements. Only one energy storing element. So this is an first order circuit. Similarly, this one only one second one also. So this is also a first order circuit. Here you have two independent L and C elements, right? So this is a second order circuit. Okay, this one, tell me about this one, the fourth one. What is the order of the circuit? Order of the circuit. See, you have L1, L2, right? So you can't combine these two, L1 and L2, because there is a resistor R here. You can't combine these two. That is why you'll get one order here and the other order here. So this is a second order circuit. Okay, if you see this L1 and L2, these two are in series, right? You can combine these two and have an L equivalent here. L equivalent here, right? L1 and L2 series is nothing but L1 plus L2, right? So you'll get an L equivalent. So this is a first order circuit. Whereas this, you can't directly add L1 L2, or they are not in series or parallel because there is a resistor R here, R2. Okay, you understood this, the difference between these two? This is how you can comment on the order of the circuit. Okay. So higher order circuits are not there in your syllabus, only first and second order circuits. Also second order circuits, you will get very less problems, only there you may get some concept based problems. For that also you should at least understand the concepts for first order and second order circuits. Okay, this is about first order and second order. Okay. And then, as I told you, transients is nothing but the instantaneous changes in the circuit when a switch is closed, switch is closed, opened, moved from one position to other, okay, or sudden changes in load, sudden changes in input, anything can cause transients. Any of these can cause transients. Okay. See this, there is a timeline if I draw. At t is equal to 0, I close the switch. Okay. Okay, this is minus infinity and this is plus infinity. Okay. T equal to 0, what I said, as just closed the switch. Okay, close the switch. That means at t equal to 0 minus, what is the position of the switch? T equal to 0 minus. T equal to 0, I close the switch. T equal to 0 minus is nothing but T equal to 0 minus is equal to minus 0.00001. That means that much of a second just before the switching action takes place. Okay, I close the switch at t equal to 0. That means t equal to 0, and what is the position of the switch? T equal to 0, I close the switch. T equal to 0 minus, the switch is open, right? T equal to 0 plus, switch is closed. Okay, you have to understand the thing is, see, minus infinity and t equal to 0. These two are what you call transient conditions. Okay, and t equal to 0 minus, t is equal to 0 minus and t equal to infinity are steady state conditions. What do you mean by steady state? After a long time after the switching action takes place. So somewhere at minus infinity it happened, and again it's happening at t equal to 0. So t equal to 0 minus is a steady state condition, t equal to infinity. That means infinity time has passed, right? Since minus infinity to t equal to 0 minus, infinite time has been passed. So it's a steady state condition, t equal to 0 minus. Similarly, plus infinity, after the switching action takes place, what happened? Again, infinite time has been passed. So this is a steady state condition. Okay. So also you have to understand one more thing. You have to understand one more thing is, see, as I told you, t equal to 0 is the switching action, maybe closing of switch or opening of switch or changing the switch. Okay, so t equal to 0 minus and t equal to infinity are the steady state conditions. Theoretically speaking, infinite time after the switching action is the steady state, but practically we'll call something as phi time constants. Phi time constants as steady state condition. Okay, practically we can't wait up to infinity, right? So we'll take phi time constant. After phi time constant, I'll define time constants. Time constant. After phi time constants, the what you call the transients will die out, and what is left is called as steady state. Okay, this is about timeline. You have to understand what are the steady states: t equal to 0 minus as well as t is equal to plus infinity. T equal to 0 minus and t is equal to plus infinity. Just after the switching action takes place, t equal to 0 plus is a transient condition. Okay. One more thing. Okay. So tell me the first one. What does this indicate? This indicate t equal to 0, t is equal to 0, and t is equal to 0. This indicate switch is closed at t is equal to 0. Switch is closed at t is equal to 0. What does the second one indicate? Opened at t equal to 0. The switch, I will call it as S. S is opened at, switch S is opened at t is equal to 0. What does this indicate? The third one? Switch is moved from position 1 to position 2 at t is equal to 0. Okay, these the switching actions are important. People usually gets confused. T equal to 0 plus, sorry, t equal to 0, the switch is closed. T equal to 0, the switch is open. T equal to 0, the switch is moved from position 1 to position 2. Okay, clear? Yeah, let's move on. And in transients, we will study something like this. Sorry. We'll have source free RC circuits, RL circuits with the source RC, RL. Okay, these are about first order circuits. Second order, source free RLC circuits. Okay, with the source RLC circuit. Okay, with the source RLC circuit. So the first one, source-free RC circuit. A source-free RC circuit occurs when its DC source is suddenly disconnected. When its DC source is suddenly disconnected, the energy already stored in the capacitor is released to the resistors. What actually happens? The capacitor gets charged to some voltage V, okay, and the all the energy that is stored in the capacitor. What is the energy stored in the capacitor? Half CV square. The energy stored in the capacitor gets released into the resistor R. Okay, the energy stored in the capacitor gets released into the resistor or dissipated into the resistors R in the form of heat energy generally. Okay, I square R losses. Okay, see, let's apply current division rule here. I'm sorry, current division rule here. IC plus IR is equal to 0. Okay, IC plus IR is equal to 0. What is IC? C dV by dt. I'm sorry. C dV by dt plus what is IR? V by R is equal to 0, right? C dV by dt plus V by R is equal to 0. So you can have different methods of solving. This is a first order differential equations. I can use something called as variable separable method. Remember variable separable method? Sorry. C dV by dt is equal to minus V by R. Okay. Or dV by dt is equal to minus V by RC. Or dV by V is equal to minus dV by V is equal to 1 by RC. Sorry, dt by RC. I'm sorry. So integrating on both sides.
lnv
Huh?
lnv
What else?
equal to
Yeah. ln V is equal to
T by S.
T by RC. Or sorry, minus T by RC.
Minus T by S.
Minus T by RC. Or V is equal to e power minus T by RC. Sorry, there is something I missed. I'm sorry. And there is something what you call integration constant, that is integral 0 to infinity. Okay, 0 plus to infinity, I can say V of 0 is nothing but V naught. That is important because this is a source free circuit. We'll assume the capacitor, or we'll take that the capacitor is charged up to V naught volts. Initially, the capacitor is charged up to V naught, and then the source is disconnected. Source free RC circuit occurs when its DC source is suddenly disconnected. Okay, so the capacitor charges to a voltage of V naught. So what happens? Ln V minus V naught is equal to minus dt by RC log V by V naught. So minus log V naught. Okay, that means log M means V is log V by V naught is equal to minus dt by RC. Or yeah,
T by
what happened? V of t is equal to V naught e power sorry, T by RC. Sorry, e power minus T by RC. V is equal to V naught e power minus T by RC. Okay, V naught is the initial voltage, or and the voltage to which the capacitor is charged. And what is T? It's the instantaneous time. RC. Okay, this can also be written as V naught e power minus T by tau. Tau is nothing but your time constant. Tau is equal to RC. Okay. Tau for a RC circuit, source free RC circuit is RC only. Okay. Okay. Tau is equal to R into C. It's a time constant. So V of t is equal to V naught e power minus T by tau. Okay. If I draw the graph of it, voltage V of t versus time t, this will be, this is V naught at t is equal to 0. Okay, at t is equal to infinity, it dies out to 0. Why it goes to zero? Because it's a source-free circuit. All the energy that is stored in the all the energy that is stored in the capacitor gets dissipated in the resistor. Okay. So for example, tell me if when tau is equal to t, okay, time is equal to, or the, sorry, t is equal to 1 tau, or okay, is equal to tau, what happens to v of t? V of t is v naught e power minus 1. What is e power minus 1 value? We check it after 5 time constants. After t is equal to 5 tau, v of t will become less than 12, less than 1% of v naught. That is why 5 time constants is practically taken as a steady state condition. Practically taken as steady state condition. Theoretically, it takes infinite time to die out, but practically, because it is less than 1%, we'll consider it to be a steady state condition. Okay.
So one doubt in the last slide,
Mm-hmm.
like these RNs here connected, but we are taking the condition that initially the voltage is V naught, and
Hmm.
so it's acting as a source, like right, sir?
Right.
Okay,
Actually, the
so
capacitor, that was my next thing
the
to tell.
the current,
Initial, huh?
the
What happened?
I have a doubt in that current direction, like the capacitor, the same current is actually flowing through the circuit, right, sir?
Yes,
So
yes, yes.
I see
That is why actually the thing is, for the sake of this nodal analysis, I took it this way.
hello, hello, hello. I'm not audible, sir. Hello. Hello.
Am I audible now?
Yes, 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 yes.
Yeah, I understood. You can take the direction the way you think, you can take it that way also. See, for the sake of taking a nodal equation, I did it this way. I can take a closed path here and I can do that. But the thing is, why I took this way is I know the current in terms of voltages in case of what you call capacitor. That's why I did it. You can take the other way around. That's why I got a negative here, right? Okay, see, and for a capacitor, the voltage as this capacitor acts as a voltage source at t equal to 0 plus. Okay, the capacitor acts as a voltage source at t equal to 0 plus. What happens? What happens? This the polarity of voltage is fixed. The polarity of voltage is fixed. Okay, at t equal to 0 plus, what happens is the current direction gets reversed. Okay, the current direction gets reversed. That's what you'll get to know. The IC, there won't be IC in this direction. All the current that's flowing will be in this direction only. Okay. This is for this just the sake of derivation. Okay.
Okay.
Shape. Okay. Yeah. Okay, you got it. So this is how a steady state is achieved after t is equal to 5 tau. Okay. So and okay, natural response. The natural response of a circuit refers to the behavior in terms of voltages and currents of the circuit itself with no external source of excitation. That means for a source-free RC circuit, there is no external excitation. The whatever the response you get, V of t equal to V naught e power minus, sorry, V of t is equal to V naught e power minus t by tau. When tau is equal to RC is an natural response. What do you mean by natural response? There is no external source, right? Whatever, only the stored energy in L and C elements are getting dissipated. That is what you call it as natural response. There is something called as forced response. What do you mean by forced response? There is an external source which defines voltage or current in the circuit, terms of voltages and currents in the circuit, then it is called as a forced response. Okay. For differential equations, you'll generally have two types. What you call them? CF plus PI. What is CF plus PI? Complementary function plus particular integral, if you remember. For the second order circuits, you'll get exact or the source with source circuits also. What does this mean is solution of a differential equation CF plus PI. You'll get one is natural response and the other is forced response. Also, you'll get something called as transient response and steady state response. Okay, what does a transient response means? When t equal to infinity, this transients gets zero or dies out. Okay, at t equal to infinity, this part of the solution becomes zero, but steady state response is the one which is independent of time. Okay, we'll see them when we see with the source RC circuits. Time constant of a circuit is the time required for the response to decay by a factor of 1 by 3 or 36.8% of its initial value. Okay, understood? V of t is equal to V naught e power minus t by tau. At t is equal to tau, or tau is one time constant. What happens? V naught e power minus 1 or 1 by e is 0.368 times V naught. So V of tau is nothing but 0.368 V naught. That is nothing but your time constant. Time constant is is defined as the time required for the response to decay to a factor of that 1 by E or 36.8% of its initial value. The smaller the time constant of a circuit, the faster the rate of decay. Okay, the smaller the time constant, the faster the rate of decay. The larger the time constant, the slower the decay. Okay. At any rate, the response decays to less than 1% of its initial value. After 5%, or sorry, 5 time constant, this is 5 tau, okay, or tau is equal to 5t, reaches steady state, okay. Steady state is nothing but after 5 time constants, which means less than 1%, okay. The response decays to less than 1%. Okay, and the key to working with the source-free circuits, only two steps. V of t is equal to V naught t power minus t by tau. So you have to find V naught, you have to find tau. And tau is equal to RC. Okay, you have to find V naught, you have to find RC. Tau. Okay, initial voltage V naught across the capacitor, time constant tau. Okay, only two steps in working out a source-free RC circuit. Next, source-free RL circuit. Okay, source-free RL circuit occurs when its DC source is suddenly disconnected. The energy already stored in the inductor is released to the resistor. So this is my inductor. It was charged to a half Li square, half Li square. Suddenly what happened? The energy source was removed or disconnected, and whatever the energy stored will be dissipated. Whatever be the energy stored will be dissipated in this resistor. Okay. See, as you said, the capacitor direction of the voltage, the direction of voltage or current in this inductor. I'll let me explain with the source circuits, then I'll give you the clear understanding of it. Okay. At t equal to 0 minus, at t equal to 0 plus, all the direction of current in a capacitor changes, direction of voltage across an inductor changes. We'll see how it happens and all. Okay. Here, if I write down the loop equation, tell me what will be the loop equation? VL plus VR is equal to 0. What is voltage across an inductor? L di by dt plus I into R is equal to 0. Similarly, di by dt, variable separable method, I into minus I into minus I into R by L. Yes. Or di by I is equal to, and again, initial volt current I of 0 is taken as I naught. I of 0 is taken as I naught. Di by I is equal to minus dt by L by R. Okay, this is how you do it. So from this again, ln I minus ln I naught. Okay, I of 0 is equal to minus t by L by R. Ln I by I naught is equal to minus t by L by R. I is equal to I naught e power minus t by tau, where tau is equal to tau is equal to, hello, tau is equal to L by R. Tau is time constant, L by R. Am I correct? Okay. What is the time constant for an RC circuit? It is RC. Time constant for an RL circuit is L by R. Time constant for an RL circuit. Again, I of t decay. This is I naught phi tau t equal to phi tau steady state condition. Okay. You again have only two what you call two steps in working a source free RL circuit. It's I naught, finding I naught, and time constant tau. Okay, I of t is equal to I naught e power minus t by tau. Tau is equal to L by R, or L equivalent by R equivalent. Okay, this is about source free RL and source free RC circuits. Source free RL and RC circuits. Okay, find the time constants of the following. Find the time constants of the following. This is 1, 2, and 3. Find the time constants of the following. Let me do the first one. Let me do the first one, everyone. See, time constant of the following. What kind of circuit is this? First thing you have to check it. This what kind of circuit is this? Whether it's an first order circuit or a second order circuit. So we have to deal accordingly. Okay, we have to deal accordingly. See here, what is the order of this circuit? It's a first order circuit, only one capacitor, right? I told you how to check whether it's a what you call first order circuit or a second order circuit. Remember, this is a first order circuit. So what is the transient condition here? The switch. What is SPST? Single pole, single throw switch. SPST is nothing but single pole, single throw. At t equal to 0, what happens? The switch is being closed. Remember, this is switch being closed at t is equal to 0. Okay, switching action. Okay, t is equal to 0, the switch is being closed. So now what you should do is, for time constant, what is the time constant for an RC circuit? Time constant tau is RC, right? R equivalent into C equivalent. Remember this. RC is nothing but R equivalent into C equivalent. R equivalent is nothing but your R Thevenin. Okay, R Thevenin as seen across the capacitor terminals. And C equivalent is also the same. Thevenin's equivalent or the equivalent capacitance. Okay, R equivalent is nothing but R Thevenin. Find R Thevenin for this circuit. Open this terminals to find R across the capacitor terminals. Okay, across the capacitor terminals. So for finding R what you should do, you should switch off the voltage source, right? Turn off the independent sources. Turning off an voltage source is nothing but shorting the voltage source. Tell me what is the equivalent resistance quickly. What is the equivalent resistance? R Thevenin after switch is closed at t is equal to 0 plus. T equal to 0 plus is nothing but the switch is closed. This is 2 ohms. 1 ohm, 0.5 ohms, 1 ohm. I need what you call resistance across these two terminals. Tell me any series parallel combinations. How to solve this? Tell me series parallel combinations quickly. Anyone? No series parallel? Hmm? Can you see any series parallel combinations? Any star delta combinations? Tell me, is there any star delta combination?
Star delta is there.
Okay. Okay. Tell me how is 2 ohms and 1 ohm? Can you see any relation or any connection between 2 ohm resistor and the 1 ohm resistor? How are they?
They are parallel.
Understood
One,
how they
one
are
and zero.
parallel?
Yes, yes.
Yeah,
Right?
1 and 0.5 in series, and 2 and 2.5, 3 are in parallel.
2 and 3 are in parallel.
2, 2.5 and 1 ohm. 2 and 1.5 and 1 ohm. All three are in parallel.
No. You have to look at between these terminals. Okay. Okay. So these two are not in series. These two are not in series. So 2 ohm and 1 ohm are in parallel because both the ends of these are connected to both the ends of this. 2 and 1 in parallel. R and 2 are in parallel. 2R by 2. Right? Sorry, 2R by 3. So what happens? This becomes 2 by 3 ohm. 2 by 3 ohm. Okay, this is how the circuit is now. This is how the circuit is now. You have to find resistor across this. Or I can write it this way. Okay, 1 and 0.5. Now tell me any other combinations?
1 and 2.2 by 3 are in series.
series, right? You understood how I draw this? Clear,
Yes,
right?
clear,
Okay.
clear.
Now 2 by 3 and 1 are in series. 1 plus 2 by 3,
5 by
5
3.
by 3, right? 5 by 3 is in parallel with 0.5. 5 by 3 into 0.5 is 1 by 2 by 5 by 3 plus 1 by 2. Okay, 5 by 15, 6, 2, 10 plus 3, 13 by 6.
No,
Baapre.
5 by
Huh? Oh, sorry, 5 by 6. I'm sorry. 6 and 6 gets cancelled. That is, this is 5 by 13. Okay, 5 by 13 is R equivalent. Okay, what is C equivalent? C equivalent is 1 by 2 or 0.5. So tau is equal to R equivalent into C equivalent. 5 by 13 into 1 by 2.
none of these.
None of these, you're getting none of these, right? 5 by 26. Just a minute, Yeah, actually, I did a mistake here. I thought you'll be saying this. You also missed with me. The circuit is wrong here. This should be this way. Understood why? See here. I'll draw it for you to understand in this way. This is the capacitor terminals.
Understood, sir.
Understood, right? I'll have a parallel here, 2 ohms and 1 ohm. Again, this is 1 ohm and 0.5. Okay. Okay, this is how the circuit is. Now, as seen, 1 and 2 are in parallel, it's 2 by 3 is in series with 1.5. Sorry,
Yes,
0.5. So 1 by 2, right? So 6 and 4 plus 1, sorry,
7 by
4
6.
plus 3, 7 by 6. Okay, this combination will become 7 by 6. 7 by 6 is in parallel with 1. R equivalent is 7 by 6 parallel with 1.
7 by
7 by
30.
6, 1 by 6,
7
7
by
by
30.
6, huh?
7
7
by
by
13.
7 by 13 is R equivalent. So what will your tau become?
7 by 26.
7 by 13 into 1 by 2 is 7 by 26. Option B. Okay, clear? Understood how the parallel combination is?
Yes, sir.
People usually do the mistake there. You should understand there is no star delta here. First thing is, people usually convert a delta to star and do this. There is no star or delta here. You should understand the concepts clearly, series and parallel combinations. Okay? Clear this one?
Clear,
Shall we
clear.
move on to the next? Okay?
Okay.
Yeah, do this for me. Do this for me. Everyone try to do this and tell me what is tau, time constant tau. Time constant tau. Any answers?
Sir, here there is no switch used to show transient or anything.
Okay, leave it. Leave about the switch and find the time constant R equivalent into L or L equivalent by R equivalent. Leave about the switch.
Okay, sir.
Just find the
Sir,
time constant.
in this case, the inductor is also opened. The equivalent inductor is also opened to
Okay,
find the
first,
resistor.
yeah. First, let me redraw the circuit. It is something like this. See, these two are in series, right? These two are in series. Can move it like this: 9 ohm and 1 Henry. Right? Can I do that?
Yes,
Now this is the circuit.
equivalent we get 2 Henry inductance.
Yes. So you have to see from these points. Okay, what is the equivalent inductance and what is the equivalent resistance? Okay, R equivalent. See, as seen from these 2 points. Short this voltage source. You'll get 2 and 2 in parallel is 1, 1 and 9 in series is 10 ohms. Clear?
Clear, clear.
As seen here, what is L equivalent?
Yeah,
L equivalent.
2.
2 and 2 Henries and 2 Henries parallel is 1. 1 and 1 series is 2 Henries. So time constant tau is L by R or L equivalent by R equivalent, which is 5 seconds. 5
1
seconds. Hmm?
1 by 5.
Oh, sorry, 1 by 5, 0.2 seconds. 1 by 5 or 0.2 seconds. Okay.
Okay, okay.
The third one, do it. Do it for me, the third one. Quickly.
Sir, is it 3 seconds?
Right. What is C equivalent? C equivalent is 1 plus 1 parallel is 2. 2 and 2 series is 1 farad. Okay. And R equivalent, as seen from these terminals. Open this. 2 and 1 in series is 3 ohms. So tau is equal to R equivalent into C equivalent, which is 3 seconds. Okay.
Yes.
Find the time constant. Find the time constant, everyone. Find the time constant.
Sir, in previous question, R equivalent is
R equivalent is, what is R equivalent?
2, no, sir. 2 and 2 is parallel.
You see, this is a current source, right? Current
Yeah,
source, what happens if you turn off a current source? Gets
yeah,
opened.
that is correct, sir. Got it.
Hello?
Yeah, got it, sir. I thought it's voltage
Okay.
short.
Okay. This one, everyone.
Sir, dependent source has any effect on this?
Find R equivalent. Find R equivalent. See, open this and as seen from these two terminals, what is R equivalent? 4 ohms. Sorry. 4 ohms, 2 ohms, and there is a, what you call, what kind of source is this? It's a Current dependent voltage source.
Yes.
Current dependent voltage source. Okay. Current dependent voltage source. What happens to the current here? So this type of circuits are called as dead circuits. How do you solve a dead circuit? How do you
Applying
solve it? Yes, apply a voltage or a current source and find it. Find the equivalent resistance and find the time constant L equivalent by R equivalent. Find L equivalent by R equivalent.
Sir, I have a doubt. Like if we just remove that inductor, then no current is flowing, right, sir? So if we then apply that current, like current is zero when this inductor is removed, right, sir? So that voltage will be,
No.
we
No,
cannot do
there
that,
is a
right?
difference actually. See, this is an RL circuit, right? The current is flowing here. If I take the current as zero here, there is no current flowing in the inductor. So I can't solve this because I'm literally making the inductor as zero or open. Okay, I should not do that. You'll definitely have to have an source, voltage source or a current source. Which one you want to take? I'll feel better is a voltage source or a current source. 1 ampere. Find voltage V. Understood? Why? Because if I take current as zero, that means the inductor doesn't, and there is no current flowing in the inductor. Okay, there is no point in finding anything. Okay, so that's why I need to have a current here. I.
I thought
No.
for
That
finding
is,
the
yeah,
equivalent
understood.
resistance.
No, to find equivalent resistance also, I need to have this. This is a dead circuit. So because of the dependent source, we insert a voltage source or a current source at the inductor terminals A and V. Okay.
Okay.
So now if I apply a nodal equation here, -1, the entering current is -1 plus V by 2 plus V minus 3I by 4 is equal to 0. I is again -1. So this will become +3. Okay. -1 plus V by 2 plus V by 4 plus 3 by 4 is equal to 0. 1 minus 3 by is 1 by 4 is equal to 1 by 4. This
3V
V by
by
2
4.
plus, huh?
3V by 4.
3V by 4. V is 1 by 3. V is 1 by 3, I is 1. So R Thevenin is 1 by 3. V by I is 1 by 3, R Thevenin. Okay. Or R equivalent. L equivalent is again given as 0.5. L equivalent by R equivalent is tau. Tau is equal to 0.5 by 1 by 3 or 1 by 2 by 1 by 3. Okay. 1 by 2 by 1 by 3 is nothing but 3 by 2.
Yes.
3 by 2 seconds. Okay.
Yes.
Yeah.
Yes.
If you want, you can try this. Take it as an homework and try this. Okay. Okay, look at this, everyone. Look at this. VC of 0. If VC of 0 is, it's an RC circuit. Okay, source free RC circuit. Okay, source free RC circuit. As I told you, only one what you call equation will have. V of t is V naught e power minus t by tau, where tau is equal to R equivalent into C equivalent. Okay, so from this, what is V naught? V naught is the initial voltage. V naught is nothing but V of 0. Okay, V of 0. See, for a capacitor, always remember, for a capacitor, the voltage cannot change instantaneously. So V of 0 minus is equal to V of 0 plus is equal to V of 0, which is equal to V naught. What happened? Someone is saying something. Okay, V of 0 minus equal to V of 0 plus equal to V of 0, which is equal to V naught for a capacitor. Okay, for capacitor. So similarly, for an inductor, what happens? Current cannot change instantaneously. So I of 0 minus is equal to I of 0 plus is equal to I of 0 is equal to I naught. Okay, current is same at t equal to 0 minus and 0 plus. Instant, that small instant, current cannot change suddenly in an inductor. That is why this holds good for an inductor. This holds good for a capacitor. Okay, so you have two steps. What are the two steps? Find V naught, find tau. Okay, find if VC of 0 is 15 volts, find VC, Vx and Ix for t greater than 0. Find it. So the first step, V naught is directly given as 15 volts, right? V naught is nothing but voltage across the capacitor is given as 15 volts. And what else you have to find? Find tau. Find tau for this time constant. R equivalent into C. Find R equivalent. Sorry, just closed it. Okay. Find V naught and find tau. Tau is R equivalent into C. V naught is given as 15 volts. Find R equivalent and C. We just did problems on finding time constant, right? Find time constant. Tell me what is R equivalent into C. Everyone, you always have to bring your pen and paper ready because this is networks. You'll understand concepts with problems. Most of the concepts will be understood only by solving some problems, at least if not bigger numericals. You have to try to do some smaller numericals so that you'll understand the concepts properly. Okay, so tau is equal to R equivalent into C. Tell me what is R equivalent as seen from the capacitor terminals. How are these two? This is series 20 parallel with 5 is 4, right? R equivalent is 4. C is 0.1. Tau is equal to 0.4. Okay, 0.4. So V C of t is equal to V naught e power minus t by tau, which is 15 e power minus t by 0.4. It is the 0.41 1 by 0.4 is 2.5 t. T in e power minus 2.5 t. Vc of t. Okay, Vc of t. We found Vc of t. Find Vx and Ix. How to find Vx and Ix? How to find Vx and Ix?
Voltage division
Yes, apply voltage division and find it.
into 12 by 20 and
So Vx of t is equal to Vc of t into 12 by 20. 12 by 20 is 4 3 is 4 5 is 3 by 5 into 15 e power minus 2.5 t. That is 9 e power minus 2.5 t. Okay. Now how to find Ix of t?
divide by that
Ix of t is Vx of t by resistor 12. So 9 by 12 e power minus 2.5t, or 3 by 4 e power minus 2.5t is I. Okay, clear with this?
Yes, sir.
So try to solve this. Vc of 0 is 45. Find Vc, Vx and I0 for t greater than 0. Vc of 0 is 45.
Is 45 raised to minus t by 4.
Okay. So again, what is R equivalent? 12, 6 parallel is 4. 4 and 8 series is 12 ohms. Okay, tau is equal to 12 into 1 by 3, 4 seconds. Okay. So Vc of t is equal to 45 e power minus 1 by 4 is 0.25 t. Okay. 45 Vc of t is 45 e power minus 0.25 t. Okay. How to find Vx? How to find Vx? Vx is nothing but, okay, current through the capacitor. What is the current? IC of t. Okay, or I naught here. I naught is nothing but C dV by dt. Right? C is 1 by 3. dV by dt is 45 into e power minus 0.25 t into minus 1 by 4. Right?
Right.
So 3 15s, 15 by 4 minus 15 by 4 e power 0.25 t. Okay, so Vx is equal to Vc plus 8 I naught, right? Voltage drop across this. Okay, Vc is already 45 e power minus t by 4, or 0.25 t, 0.25 t, plus 8 into 15 by 4 is 2 into 15, it's minus 30, minus 30 e power minus 2.5. Sorry, 0.25 to 45 minus 30 is 15 e power minus 2.5, 0.25 t. So 15 e raised to minus 0.25 t. Clear?
Please.
Find this one, v of t for t greater than 0 and w of 0. W is nothing but energy. Find this. So again, two steps. RC circuit, find V naught, find tau. You already know how to find tau. Finding V naught. What is the status of switch here, everyone? Status of switch is
Open.
what is happening to the switch?
Open.
Opened at t equal to 0. The switch is getting opened at t equal to 0. That means t equal to 0 minus the switch is closed. Okay, you have to find V naught. For finding V naught, what you have to do? You have to take the condition at t is equal to 0 minus and draw the circuit. At t equal to 0 minus, what is the position of switch? The switch is closed. Plus minus. So again, remember there are two steady states. What are the two steady state conditions of time? 0 minus and infinity, plus infinity. These two are steady state conditions. Okay, steady state, at steady state, what happens to the capacitor for DC? It's an open circuit, right? It becomes an open circuit. 24 volts, 6 ohms, 12 ohms, and 4 ohms. So find the voltage across this. Find the voltage across this. Understood what I meant?
Yes.
Okay. So what happens now? This is 24, 6, and this is 12 parallel with 4 is 3 ohms, right?
Actually,
Hmm.
um,
Find V of 0 here, or 0 minus. V of 0 minus is equal to 24 into 3 by 6 plus 3, 9.
8.
8 volts. V of 0 minus is equal to 8 volts, which is also equal to V of 0 plus or V naught. What happened? You are saying something? Any doubt?
No. I was just thinking about the equivalent resistance.
Okay. 12 into 12 parallel with 4 is 3. Okay. 12 parallel with 6 is 4. 12 parallel with 4 is 3. Okay. I got stuck the screen. Okay. Find R tau. Find equivalent and find tau.
Equivalent is 2 and tau is 1 by 3.
R equivalent is 12 parallel with 4. After t equal to 0 plus, tau is always at t equal to 0 plus. Okay.
Okay.
For V naught, you have to use t equal to 0 minus, because V naught of 0 minus is equal to V of 0 plus is equal to V naught. Okay. Also, for energy, W of 0, which is equal to half CV square, V naught square actually. W of 0 is nothing but V of 0. Half C into V of 0 square. Half into C is 1 by 6 into V square is 8 square. 8 into 8. Okay. 4s, 3s, 2s, 16 by 3 joules. Okay. The energy is 16 by 3 joules. Okay. And you have to find V of T. Find R equivalent. R equivalent is 3 ohms. Okay. Tau is equal to R equivalent into C. 3 into 1 by 6 is 1 by 2. Tau is 1 by 2. V naught is 8. So V of T is 8 e power minus 2t. 8 e power minus 2t. Clear everyone?
Please.
Am I going fast, or are you able to understand this? Am I going fast, or are you able to understand? Clear, right? So
Please.
two steps, only 2 steps, finding V naught and finding tau. To find V naught, use t equal to 0 minus. To find tau, use t equal to 0 plus. Only 2 conditions. Okay? Okay? Now find this. Find I of t for t greater than 0. Find I of t for t greater than 0. What kind of circuit it is? It's an RL circuit. What is the condition of switch? Switch is
Open.
opened at t equal to 0. Switch is opened at t is equal to 0. So again, find I of 0 minus I of 0 minus, how to find t equal to 0 minus, what is the circuit? Switch is closed. This is my circuit, 40 volts. T equal to 0 minus is a steady state condition. Okay, what happens to the inductor? Inductor becomes short circuit for DC. Short circuit for DC. Right? 2 ohms, 4 ohms, 12 ohms, 16 ohms. See here, this is what my current is, I of 0 minus or 0 plus. So when this is short circuited, no current flows through this resistor, right? I can remove this resistor. Current always flows through the least resistive path. Okay, so find I of 0 minus. So what is the equivalent resistance? 12 parallel with 4 is 3. 3 and 2 is 3 plus 2 is 5. 5 ohms is equivalent resistance. Current is 40 by 5. Okay, 40 by 5 is 8 amps. 8 amps flowing here. I need I of 0 minus 8 into opposite resistance 12 by total 12 plus 4 16. 8 twos to 6. So 6 amperes. 6 amperes is I of 0 minus, which is equal to I of 0 plus or I of I naught. Okay, I got I naught. And the next step is to find tau. Tau is L equivalent by R equivalent. Am I going fast? Are you able to understand me? Tell me R equivalent. To find R equivalent, use condition T equal to 0 plus. T equal to 0 plus, the switch is open. Okay, so as seen from the inductor terminals, how are these two? These two, 4 and 12 are in series. That is 16 ohms, 16, 16 parallel. R equivalent is 8 ohms. So tau is L by R, 2 by 8, 1 by 4. Okay, I of T is I naught. I naught we got it as 6. 6 e power minus 4t. I naught is 6 e power minus 4t. Clear? Shall I repeat or is it clear?
Just show the last slide, sir. Yes, missed something. Oh, okay, okay. Got it.
Okay.
Yes.
Try to do this. Vc of 0 plus I of 0 plus Vc of t for t greater than 0. Try to solve this. See what is this condition of switch here? Tell me what is the condition of switch here? The switch is
So, steady
closed at t equal to 0. What is happening? Is it a source free circuit or a source circuit with source circuit?
with source.
With source at t equal to 0 plus. What's happening at t equal to 0 plus?
T equal to 0 plus, this is short circuited, this current source.
Yes, at t equal to 0 plus, the circuit, whatever the current source, it's getting short circuited. That means no current ever flows in this circuit because of this source. Okay, so this is a source free circuit. Okay, this is, sorry, this is a source free circuit. Okay, remember we are actually dealing with source free circuits now. Okay, so
Okay.
understood. So find I of 0 minus or I of 0 plus is what you need to find. Okay, I of 0 plus. For that, it's a capacitive circuit, right? RC circuit. Find VC of 0 plus or VC of 0 minus, which is same as 0 plus. At t equal to 0 minus, what is the position of switch? The switch is open. That means the circuit is something like this. So, t equal to 0 minus is a steady state condition. For steady state, the the capacitor becomes open circuit. 0.1 ampere, 200 ohms, 50 ohms. Find V of 0 minus, VC of 0 minus. No current flows through this. So VC of 0 minus is 200 into 0.1, 20 volts. Clear? VC of 0 minus is 20 volts.
Yes.
So what is VC of 0 plus? What is VC of 0 plus? 20 volts, right? Voltage across a capacitor cannot change instantaneously. VC of 0 plus, I got it. Then VC of t. Need to find time constant. For finding time constant, what should I do? At t equal to 0 plus, t is equal to 0 plus, what happens? This circuit is being shorted, so only this is what is left. Okay, so this is 50 ohms.
200 ohms. Okay, it's also on. Okay.
It's getting shorted, right? This is VC. So tau is equal to R equivalent into C. Just 20 micro into 50 ohms, 100 micro, or 1 by 100, 1 by 10, 0.1. Okay, tau is 0.1. So VC of t is 20 e power minus 10t. This is VC of, okay, VC of t. I of 0 plus, I of 0 plus is 0. Okay, no current flows through. Or, okay, rather, I'm sorry, I of 0 plus is not 0. Just after the switch is closed, my capacitor acts as a voltage source of value 20 volts. Okay, at t equal to 0 plus, the circuit is something like this. I have a voltage source, 20 volt source, and a resistor here. This is 50 ohms resistor. Rather, no current flows through this. All the current will flow here only. So I is 0. Okay, anyhow I is 0. I of 0 plus is 0. Because it's a resistor, current can change instantaneously. So I of 0 plus is 0. VC of 0 plus is, how much I got? 20 volts. VC of t is 20 per minus 10t. Clear?
Sir,
Is
there
it
is
clear?
one doubt, sir.
Mm-hmm.
While calculating this time constant, actually, the unit should be in seconds or something.
Yes. Actually,
So
you'll get it in seconds only.
50
Okay.
into 20 microfarad,
Mm-hmm.
1000. So 1000 into 10 raised to minus 6. So 10 raised to minus 3 will be getting it will be in milliseconds, right, sir?
I'm sorry. I'm sorry. Yeah. 10 milli. Okay. 10 milli. 10 into 10 power minus 3. 0.01, right? Let me see. 10 into 10 power minus 6. 10 into 10
10
power 100 into 10 power minus 6 is.
actually is
Sorry, this is 1000
1000.
into. Yeah. I'm sorry. This is 10 power minus 3 or 1000 t. Okay. This will be 1000 t.
Okay,
Clear, right?
very good.
Okay. As you reminded, let me give you this one also. See, for an RC circuit, tau is equal to R equivalent into C. For an RL circuit, tau is equal to L by R. See, e power minus t by tau. The units, this is unitless. That means tau is having units of seconds. Okay, so tau is having units of second. That means R into C is seconds. Okay, L by R is seconds. Okay, unit wise, I can equate these two. RC is equal to L by R. Okay, the units are seconds for this. Okay, so okay, or
Okay.
What are the units for? I can say R square C. What are the units for R square C? If someone asks you, what are the units of R square C? It is
Henry.
R square C is L, which will have Henry's. See, this is not equal. I'm equating in terms of units. Okay. R square C is L. That means you'll have the units as Henry. Okay. Or L by R square. What are the units? Farads. R by L square. What are the units? Farads. Okay.
Yes.
Or tell me RC by or this by this RC by L by R is
1.
R square. Yeah, this is the units are 1. R square by C by L is 1. So R square C is again L. R square C is L is equal to Henry's. That's what I got here, right? Okay. Clear. This is okay. If I multiply these two, what happens? RC into L by R. What are the units? Second square, right? Second square. R gets cancelled. L into C or root LC is seconds. Okay, root LC is seconds. What is 1 by root LC? 1 by time is frequency, hertz. Okay, 1 by root LC is nothing but frequency, hertz. Okay, so these are some important units you have to remember. Okay.
Okay.
Yeah, try to do this. Find Vc of 0 plus I of 0 plus Vc of t for t greater than 0. What is the position of switch? Position of switch.
Steady state it was 1.
At t equal to 0, the switch is moved from position 1 to position 2. Okay, position 1 to position 2. To find, it's a capacitive circuit. To find Vc of 0 minus or Vc of 0 plus, what should I take? At t equal to 0 minus. T equal to 0 minus is a steady state condition. Steady state capacitor acts as an open circuit. So at steady state, the switch is at position 1. Okay, so this is my open circuit. 50 volts. So this is Vc of 0 minus, which is equal to 50 volts directly. This is 50 volts. Okay, now find tau. For getting tau or for finding tau, what should I do? At t equal to 0 plus. T equal to 0 plus, the switch is moved from position 1 to position 2. This is the circuit now. This is the circuit now. 800 ohms and 2 microfarads plus minus Vc. So tau is equal to R into C. 800 into 2 into 10 power minus 6. 1600 or 1.6 into 10 power minus 3. Okay. One point six into, so V of t or Vc of t is equal to V naught is 50 e power minus 1000 t by 1000 by 1.60. Okay, you may simplify it. Okay, that is Vc of t. And what else is asked? I of 0 plus. What is I? I has not been given anywhere. Okay, this call this as I. Okay, find I of 0 plus. T equal to 0 plus, what happens? T equal to 0 plus, this acts as a voltage source of 50 volts. So I will become, I of 0 plus will become T equal to 0 plus, if I draw the circuit, this is something like this. This is a voltage source of value 50 volts. Okay, 800 ohms. This is my I. I of 0 plus will become 50 by 800. Okay, 1 by 16 amperes. Okay, clear?
Yeah.
Do this similar one.
And the last slide,
Hmm.
like before the switch was moving to the position 2, it was in
Mm-hmm.
steady state. So the capacitor acts as open circuit, and can we think of it as like in the steady state,
Hmm.
the since there is only one resistance and the capacitance will get fully charged to 50 volts.
Yes, that's what actually it means. When I say at steady state, what happens is at steady state, it takes actually an infinite time to get fully charged or fully discharged. In the first place, if it has to get fully charged, that means it is at position 1 for infinite time. That is from minus infinity to t equal to 0 minus, it is in this position 1. That is that 50 volts is getting, or the capacitor is getting charged to that voltage. Okay.
Okay.
There are some good problems. I don't want to go into problems actually, or what I can say, uh, numericals, more of numericals. I just meant only the, what do you call, concepts parts. That's why. Next, what is a unit step function? Unit step function is something like this, represented by u of t. What is u of t? U of t is defined as 1 for t greater than 0. U of t is equal to 1 for t greater than 0, right? And is equal to 0 for t less than 0. It's undefined at t equal to 0. Okay. Unit function or is not defined generally at t equal to 0. Okay. So that's it. That is what I want to say. Step response of an RC circuit. Okay. Step response of an RC circuit is something like this. So this switching action can be replaced with u of t. That means what does this mean? At t equal to 0 plus the voltage source, sorry. Okay, at t equal to 0 plus the switch is closed. That means this voltage source is added to the circuit. T equal to 0 minus, what happens? The switch is open, the voltage source is 0. Right? That can be achieved by adding a unit step function here. I replace the switch with u of t. Okay, the step response of a circuit is its behavior when the excitation is a step function, which may be a voltage or a current source. Okay, okay,
Right.
what happened? Clear, right?
Clear.
So again, assuming V of 0 is V naught, or V of 0 is equal to 0 minus is equal to 0 plus, because this is a capacitor. Okay, V of 0 minus V of V of 0 minus is equal to V of 0 plus is equal to V naught. Okay. So in this, if I see, I can write it like this again, same. If I take this as current I, okay, IC, this is IR, Tell me the nodal equation. Node equation is IC plus IR is equal to 0. What is IC? C dV by dt plus IR is V minus, I'll call this voltage as V, right? This voltage is V. V minus Vs into U of t by R is equal to 0. Okay, again variable separable method. dV by dt plus V minus Vs, or I will directly write it, V by RC, okay, is equal to Vs by RC, okay, for t greater than 0, right? U of t can be replaced as t greater than 0. dV by dt is equal to minus of V minus Vs by RC. Correct? dV by dt equal to minus of V minus Vs by RC. So dV by V minus Vs is equal to minus dt by RC. Okay, introducing, integrating both sides and having initial conditions, what will I get? Log V of t minus Vs, okay, log V of t minus Vs minus log V of 0 minus Vs is equal to minus t by RC.
Sorry, sir, I am not able to see the slide.
Oh,
Like it's stuck in the last.
acha. Now,
The last thing I can see is dV by V minus Vs. Okay, okay. Right now, equal to minus T by RC.
okay, clear, is equal to minus t by RC. This is clear, right? ln V minus Vs by V naught minus Vs is equal to minus t by RC. Clear? Able to see this one? The
Yes, yes,
box now? Okay.
yes.
Taking exponentials on both sides, what you'll get? V minus Vs by V naught minus Vs is equal to e power minus t by RC. Okay. V minus Vs is equal to V naught minus Vs into e power minus t by RC, or V is equal to, or V of t is equal to Vs plus V naught minus Vs e power minus t by tau. Okay. Okay.
Last slide. Last slide. Just to get back. Okay.
Okay. Okay. So what is Vs? Vs is nothing but the source voltage. When will the at t is equal to infinity, what happens? It's a steady state. V will become Vs. Okay. So V of infinity is nothing but Vs. Okay. So V of t can be written as V of infinity plus V of 0 minus V of infinity into e power minus t by tau. What is tau? Tau is equal to RC. This is important. V of infinity plus V of 0 minus V of infinity into e power minus t by tau. Okay? Okay? I'm sorry. Clear?
Clear.
Yeah. Again, let me write it this way. V of t is equal to V of infinity plus V of 0 minus V of infinity e power minus t by tau. So if you see this, I'll write it one in and again a different way. V of 0, or V of 0 plus V of infinity is taken common. This will become 1 minus e power minus t by tau. Okay, I can write it this way also, right? Right? Agree? Both are same?
Uh,
Okay.
Sorry, sir. Clear.
Hmm? What happened?
It's not clear, sir.
Okay, I'll write one more step. So this is V of infinity plus V of 0 into e power minus t by tau minus V of infinity into e power minus t by tau. Writing this V of 0 into e power minus, oh sorry, I missed this one, sorry. V of 0 into e power minus t by tau plus V of infinity into 1 minus e power minus t by tau. Now clear?
Okay, okay.
V of t. I'll write down two equations of these. Okay, these two. Observe these two. I can write it something like this: CF plus PI. This is equal to CF plus PS, complementary function plus particular integral. That means, see, what is V of 0 and V of infinity? Sorry, what is V of 0?
Initial condition.
Initial charge on the capacitor. Initial charge in the capacitor. V of infinity is nothing but the source voltage, right? Vs. Remember the source voltage, whatever the voltage is applied. Okay,
Yes.
the source voltage. Okay, so V of 0 is nothing but the initial voltage or initial charge of the capacitor. So in this, in the CF plus PI, this part is called natural response. Why it is called natural response? And this is called forced response. Important. Why it is called natural response? Because there is no external force for this. V of 0 e power minus t by 2. Remember source free RC circuit. Source free RC circuit, this is what you get. When there is no source, whatever you get is this one, V naught e power minus t by tau, right? Remember?
Right, right.
So this is called natural response. This is forced response. Because of the source present, this is what you are getting. So this is called forced response and this is called natural response. Okay. And this one, coming to this one, this is called steady state response. Not Sushant Singh Rajput. This is our steady state response and this is transient response. Why transient response? Because this decays with time and at infinity this will be 0. And t equal to infinity, this will die out. So this is transient response and this is steady state response. This is natural response and this is forced response. Natural response and forced response. Okay, clear? Clear, right? So steps in solving RC circuit, step response of an RC circuit. You again, V of t is V of infinity plus V of 0 minus V of infinity to e power minus t by tau. Tau is equal to RC. Okay, you need to find V of infinity, V of 0 and tau. Three steps. Find V of 0, V of infinity and time constant. Three steps for step response of an RC circuit. Okay. Okay. Next, step response of an RL circuit. You can again analyze it, or there is one concept called as duality, principle of duality, if you remember. Okay, draw the dual of this circuit. Draw the dual of this circuit. In the last class, I told you how to draw the dual, right? If you draw the dual of this circuit, you'll get an RL circuit. Okay, you'll get a current source anyhow. Okay, it's an RL circuit. So what you can write is, I can take a current source here. Okay, RL circuit. So what happens? I of t is equal to I of infinity plus I of 0 minus I of infinity to e power minus t by tau, and tau is equal to L by R. Okay, Instead of deriving, I'm using the principle of duality, and this is what I'll get. I of t is equal to I of infinity plus I of 0 minus I of infinity e power minus t by tau, and tau is equal to L by R in case of RL circuits. Okay, and I of 0 is the initial charge in the inductor. I of infinity is the steady state current in the inductor after switching action. This is before switching, this is after switching, and tau. Okay, 3 steps. Find I of 0, I of infinity, tau. 3 steps for RL circuit also. Step response of an RL circuit. Okay. Okay. So finally you have see source free RL or RC and RL circuits. Okay, source free RC circuit. V of t is equal to V naught e power minus t by tau. Source free RL, I of t is equal to I naught e power minus t by tau, and tau is equal to RC, tau is equal to L by R. Okay, with the source or step response. Step response for RC. For RC it is V of t is equal to V of infinity plus V of 0 minus V of infinity e power minus t by tau. Tau is equal to RC. RL same I of t is equal to I of infinity plus I of 0 minus I of infinity e power minus t by tau. Tau is equal to L by R. Okay. Okay, only 4 formulas for the entire transients, nothing else. Okay, so just remember these 4 formulas. Okay, even you don't have to remember all the 4 formulas. Even if you remember these 2 are enough. Okay, put t equal to put v of infinity as 0 or I of infinity as 0. Okay, forced response is 0. What happens? It will become the same. V naught e power minus t by tau, or v of 0 e power minus t by tau, and I of 0 e power minus t by tau, right? Taking v of infinity and I of infinity 0 is nothing but will give you source free. Okay, only 4 formulas, rather only 2 formulas, these 2 formulas for the entire transients. Okay. Okay, note it down, these 4 formulas. These are important to solve any problem from transients, first order circuits. Okay, first order circuits. Okay, any problem you get from transients, you'll definitely get from first order circuits only. Second order circuits, you'll mostly get concepts. Okay. Okay, clear this one?
Clear.
Okay, we'll continue in the next class. Okay, so it's already 10:30. Okay, remember these 4 formulas. We'll continue in the next class. Okay,
Thank you.
thank you. Clear, right? Any doubts in today's class? Okay.